As a final wrap up, when we are doing a statistical test and starting our analysis procedure, we need to consider three ideas in sequence. Okay, so we first need to think about a significance level, and actually that's something that we as researchers can control. We can state the significance level, and that's usually defined in the context, like what is significant. Um, and then once we determine significance, we want to think about effect size, and this was mentioned at the end of the last video, but the overall concept is how large of an effect in the population is important. Okay, and so you can imagine that in different populations, different things, the effect size is going to vary. Okay, um, so we don't get into the measurement of this here because it is sensitive to the population and it's also sensitive to the method that we use to analyze the data. Okay, so anyway, we think about effect size. Then once we've identified, okay, how large of an effect is important, then we think about, okay, how confident do we want our study to be to detect this effect size? And that's the idea of power. And so we get pretty close to calculating power in this class, and we could if we had more time, but we don't. So the idea here is that all power is when we look at a very specific alternative, and I can't emphasize that enough. You have to do this on a case-by-case basis for any individual alternative hypothesis that you develop. But it's a probability that you reject the null when the alternative is true. So, right. So it's connected to some type of error, okay? And so before I get there, I want to just remind us that when we think about significance level, right, we capture significance level, or we represent it by alpha. And that is just also our probability of a type 1 error. And that we can set, okay? And we've discussed these, and this is a table that I took out of the book. So big idea is that if HO is true, but we reject it, that's when we have a type 1 error. And similarly, if we know that if the alternative ends up true, but we reject or we fail to reject the null, that's a type 2 error. It's a mismatch in reality. Okay. Then when if beta we represent as the probability of a type 2 error, right? That's right there. All we do to calculate power is 1 minus beta. Okay? And we don't, like I said, we would calculate beta if we had more time in the course, but it's a little intricate. And given that we have to calculate it for a very specific alternative, we have to do it potentially for multiple cases. So we just leave it to software. And literally when you have data and you going through and setting these things up, you can click a few buttons and it'll give you the power. So you will have a homework assignment question in your homework assignment that you use an applet, and that helps, and that'll calculate power for you. So at least you have an idea of what you could do to calculate power. But ideally, when we think about this number, this power number, we want it to be about 0.8. It could be higher, but typically when we have higher powers, we have to have a very large sample size. And then also there is a relationship between power and alpha. If we have a higher alpha, typically then our power is lower. So we have to sort of balance what we want, or which one we need more. Do we need a higher power, or do we need a higher alpha? So we need to just play that balancing act. Okay. And then lastly, so power, don't worry too much about it. Just kind of be aware of the overall idea of power. And then the other thing, so we've talked about how to calculate alpha that we choose, okay, or it's defined in the context. Beta is just, or power is 1 minus beta, whatever our type 2 error probability is. And then effect size, we haven't talked about how to calculate that. I did mention that it is specific to the context and the calculation methods. So we have to use our sample data to generate the effect size, and so that's something that we don't have control over. Okay, we actually have seen one type of effect size, and it's correlation coefficient. That is one type of effect size. So we can have Excel calculate these, but we need to work in the context to determine the effect size overall. So that's it. After many, many long videos, thank you for enduring, um, and I hope you have fun with working with the one sample z tests and all the different things connected to tests of significance.